Hello all, welcome to AI Educator. In this video, let us learn about artificial neural network. Artificial neural network is known as a feed-forward neural network or fully connected neural network. It has multiple names. Artificial neural network is simply called as ANN. ANN is a deep learning model inspired from the human brain. Similar to the human brain, ANN has multiple neurons interconnected with each other, where output of one neuron becomes the input of other neuron. Here, every circle or a node represent artificial neuron. Every node will receive input from some other node or from an external source and compute the output. Each input has an associated weight which is assigned on the basis of its relative importance to other inputs. The node applies an activation function on the cumulative sum of input and weights added with a bias B. As you can observe here, we have the two inputs x1 and x2 and they have assigned a weights of w1 and w2 and there is a bias of b. Then the cumulative sum will be x1 w1 plus x2 w2 plus b. Now let us discuss about different layers of artificial neural network. ANN has three type of layers: input layer, hidden layer and output layer. Input layer. This layer consists of neurons that receive input and pass them on to other layers. The number of neurons in the input layer should be equal to the attributes or features in the dataset. There will be no computation performed in any of the input nodes and there will be only one input layer. Next, hidden layers. Hidden layers is present in between the input and output layers. The nodes present in hidden layers are called hidden nodes because they have no connection with the outer world. These hidden nodes perform computations and transfer the information to output layers. The number of hidden nodes in the hidden layer is a tunable parameter. We can give as many nodes as we want, and we can also have multiple hidden layers. Next, output layer. The nodes in the output layer are responsible for computing and transferring information from network to the outside world. The number of nodes in the output layer depends on the type of model you are building. For classification, it will be the number of classes that you are trying to classify. And for regression, we will be having only one single node. And there will be only one output layer. Now, let us discuss about the forward propagation. Propagation means the flow or the direction. Forward propagation means moving in the forward direction. Here you can see an artificial neural network of multiple layers. We have an input layer with 4 nodes. We have the first hidden layer with 3 nodes and the second hidden layer with 2 nodes and the output layer with 1 node. And the data is sent through the input which is x1, x2, x3 and x4. Now for every connection there are weights assigned and we also have the bias for the hidden layers. There will not be a bias for output layer. Now let us consider Z is the cumulative input that goes to a node. Let us consider the input that is going to this particular node. Let us call it Z11. Then the Z11 will be Z11 is equals to x1 w1 plus x2 w1 plus x3 w1 plus x4 w1 plus a bias b1. Then the node will perform some activation function on this input. Let us call the output of activation function as O. So output of this particular node will be O11, which will be an activation function on Z11. In a similar way, for this node, we will be getting an input of Z12 and output of this node will be O12. Again, in a similar way, for this node, we will be getting an input of Z13 and the output of this node will be O13. Now, we move forward from hidden layer 1 to hidden layer 2. The input received for this particular node will be Z21, which is Z21 is equals to O11 W211 plus O12 W221 plus O13 W231 plus bias B2. This node will perform an activation function on Z21, which will be O21. In a similar way, for this node, we will get an input of Z22 and output of this node will be O22. Now we move forward from hidden layer 2 to the output layer. For this node, the input we get is Z31, which is Z31 is equals to O21 W311 plus O22 W321. This node will apply an activation function on Z31, which will be the O31. Since it is the output layer, it will give us the predicted output y hat. Now we will find the loss by finding the differences between the expected and the predicted results. Here, a point to be remembered. We can have different activation functions on different layers, but we cannot have a different activation function inside a single layer. All the nodes in a layer will have the same activation function. I can have ReLU activation function in hidden layer 1 and TANH activation function in hidden layer 2. But I cannot have activation function ReLU for this node and sigmoid for this node and TANH for this node. I cannot have like that. This entire layer will have only one single activation function, whether it will be ReLU, TANH or sigmoid. Now let us discuss about the training process of artificial neural network. In the training process, we perform forward propagation and will find the loss. Then we do the back propagation and try to reduce that loss by updating weights and bias. One forward propagation and backward propagation is called an epoch. We try to perform multiple epochs to reduce the loss. We will discuss more about this back propagation and weight updates in the back propagation chapter. In the next video, let us look into the neural network playground.